How does induction generators work? Welcome to this presentation on how induction generators work. Today, we'll explore their working principle, step-by-step operation, and key characteristics that make them useful in renewable energy systems like wind and hydropower plants. Introduction. An induction generator produces electricity when its rotor is spun faster than the synchronous speed of the stator's magnetic field. This requires a source of reactive power, either from the grid or from capacitors, for excitation. The prime mover, such as a wind turbine, supplies the mechanical energy, which is then converted into electrical energy and delivered to the AC system. Stator energization. The process begins when an AC supply energizes the stator windings. This creates a rotating magnetic field inside the stator, which is essential for initiating motor and generator action. Motor action. Initially, the rotor behaves like a motor. It is pulled into motion by the rotating magnetic field of the stator. At this stage, the machine consumes a small amount of power. Prime mover action. Once a prime mover, such as a wind turbine or a water pump, applies mechanical force, the rotor is driven faster than the synchronous speed of the stator's field. This is a crucial step that transitions the machine from motor mode to generator mode. Negative slip. When the rotor spins faster than the stator's rotating field, it produces what we call a negative slip. This means the rotor conductors cut the field lines in the reverse direction, which is the key condition for generating power. Rotor current and field. This reverse cutting of field lines induces a current in the rotor conductors. The rotor current then produces its own magnetic field, which interacts with the stator's field. Stator voltage and power generation. As the rotor field interacts with the stator field, voltage is induced in the stator windings. This induced voltage pushes active electrical power back into the AC system, completing the process of power generation. Reactive power demand. However, induction generators cannot generate their own excitation. They need reactive power to establish and maintain the magnetic field. This reactive power is supplied by the grid or by capacitor banks connected to the system. Key characteristics. To summarize, induction generators are asynchronous machines, meaning the rotor never rotates at exactly the same speed as the stator's magnetic field. They require external reactive power, unlike synchronous generators, but they are highly efficient and widely used in renewable energy systems, especially wind and hydroelectric plants.